Hello to everyone. So sorry not to be there, but this works too, I guess. I will continue what Ben has already informed you. It's a bit tricky to split the talks in three topics because some of the content is interleaving. So some steps are necessary for each of the talks, so some points will be repeated or maybe further details will be explained, so just bear with us. So Ben has already mentioned our project and the research into the computer science part of the linguistics, and some of these results have already been published. Some of the results we are still working on. And for example, the thing that Ben has explained is still unpublished, this propagation algorithm, which kind of selects the order in which to fill the sentiment values into the dictionary and how to reiterate the spelling from the information from where it's mostly available to where it's sparse in the dictionary. And that's in the writing now, but some of the stuff like how to assign value to a graph of sentiments to a graph from the available values has already been published this year together with sense labeling, but that's something that we will not focus on today. We are talking about sentiment analysis, which is the classification of emotions that are that can be assigned to some text, whether it's purely just classifying it as negative, neutral, or positive, or to assign some numeric value, which is usually normalized, usually from -1 to 1. And the starting point of such computation is the word, or a lexeme, as it's said in linguistics. So lexical dictionaries are the available ones are filled by people, and what it's usually the case for words that often there are words with several meanings, or that the meaning of a word is not immediately clear. So these are terms of polysemy and homonymy, which relate to either two or more related meanings, or meanings that are quite unrelated and very distant one from another. For example, if you think of a nickel, you might think of the coin actually, but also the same word is used for the metal of which it is made. And this is not just the case for nouns. For example, the verb to run can mean some physical activity, but also to run for the office, more in some indirect speech, or to start a computer and to run a program on the computer. But even further away, or for more distant meanings, for example, if you think of bank as a financial institution, the same word is used also for the land at river edge, or for example, boot can be a piece of footwear, but also the luggage of a car. So the meanings of a word may be different, and what the sentiment dictionaries often do is they just list a single entry for one word, just like the other dictionaries, but some, of course, then list their syntactics and semantics. And you can see that, for example, SentiWordsNet is a sentiment dictionary that does differentiate between various entries of the same word. But that is so because it is connected to the WordNet semantic knowledge base, which contains this synsets, which is just kind of a hierarchy or classification of the meanings or categorization of words, some kind of ontology. And what you can see here that those values for different senses are different. Pride as a group of lions which is a meaning that we've learned by chance when investigating this word, is neutral, so neither positive nor negative, but it's rather positive in the other more usual sense. And that is also the case here for the senti words sentiment dictionary, but you can also see that the sentiment values are differently presented. Some are just continuous values between -1 and 1, and here there are more like classified in different categories in some discrete points. I guess this is probably because it's filled with humans, and it's hard to subjectively assign such a detailed values. Is it 0.25 or 0.28? I guess the humans are not that sensible in that sense. Furthermore, there are sentiment dictionaries that have different dimensions or consider emotions in various aspects, like sensitivity, attitude, attention. So you can see that the polarity score, which is kind of a representative score, single representative score that you can use for the word pride in Sentiknet dictionary, has these 4 dimensions here, but it's propagated from sensitivity. So others are just 0. I don't know whether this is the case and whether people would agree on that. You saw that the same word is less positive in the previous dictionaries. So dictionaries vary between them, and our analysis can be adapted for each of those. Here, for example, we could use some interpolation or fill continuously the values between those discrete marks. So, for example, when you think about the word virus, nowadays everyone would think about coronavirus, I guess. That's the first thing that comes to mind, sadly. But if you look at it at Sentiknet, which is the largest sentiment dictionary and the one that we mostly focus on, you see that this word is negative. But in Sentiwords net dictionary, in the same primary meaning of virology, it's neither positive nor negative, so neutral, and it can be only positive or when it's connected to computer virus, which appears rather strange, and it can also be quite negative in the third meaning. So these values appear a bit inconsistent throughout those dictionaries, and that reflects the subjectivity of the topic itself. So it's a hard topic. Here, what we have integrated already in the Congrazinet application is just the listing of WordNet synsets. So that is the meanings. When you type in the word you want to explore, you will immediately see in our application the listing of the synset, which express distinct concepts that this word can have. But what is the main point of the application is how to produce the sense from corpus. So how to come up with the senses without any knowledge base, any ontology, but from the use of the word from various amounts, different amounts of texts and large amounts of text. So this graph, as you can see, this will be our product of the Congrazinet graph for the word virus. And you can see on the right side there are words, related words based, related more to the computers, while on the left side, these are more words related to illness and are further separated into microorganisms like bacteria, germs, and so on, and to the effects of the virus in the yellow, like infection, HIV. So we will use these clusters in the graph to separate different meanings of the word and to enrich the sentiment representation of a word, and to provide what we call sentiment potential of a word, which is kind of sentiment modular sense. And for example, if you look at another word, country, you can see here that we obtain also different meanings, like the territory of the US and states, several countries like India, China. So these are examples of countries. We obtain words that are related to area, like region, city, state, continent, and so on, but also more high-level meaning of related to society, like people, world, culture, and so on. For example, the typical word often used in linguistics in this area of research is chair, which has two very distant meanings, which is also visible already in the graph. This large part in the upper part of the figure is related to furniture and further refined in the subgraphs, but the lower part is related to conferencing and words like professor and dean, PhD, director, and so on. What we do, and what Ben has already explained, we use a tagged corpus and then apply NLP techniques and focus on some syntactic dependency. So that's how the words are related, how the words appear in text with which relations, and represent that with graph, where the nodes are lexemes, and the edges represent those syntactic dependencies. Both edges and the nodes are have their own properties, which are both syntactic properties and the summarization properties from the corpus. So we produce, in particular, for the sense identification, in order to conceptually identify the associated lexemes, we use the coordination type dependency, which connects the words with logical connectives and or. So it's clear that and typically conjoins words from some abstract category which are closely related, or would even represent alternatives and may appear that these are more distant terms, but they are also from the same semantic domain, like in the same category of the terms. So starting from going to the application, you would first have to choose a corpus from which to extract. By choosing a corpus, you would be able to culturally research meaning of the word related to that corpus. We usually, in the examples that I will show, relate to N1010 English corpora, which is 38 gigaword corpora of English web texts. So it's huge, and it will represent the general meaning of the word, not that specific like in medicine or in mathematics and so on. And corpora can also represent, it can be time-stamped, so it can represent the meaning of the word in some specific time period. So when we researched the word virus, we did not find corona, because of the large scale of this N1010 corpus. But if we were presented and if such a corpus were available that would represent texts from the last year and a half, I'm sure it would come up as a prominent meaning of the word virus. So choosing the corpora is the first thing. Then you select the word you want to explore and input the word. And part of speech. There are words that have the same spelling in noun and verb form, so that is also really important. And here are the steps that Ben also already commented. So first we construct a friend network, then a friend of a friend network by merging friend networks of the main nodes. Then we identify most prominent nodes in the graph by using some graph centrality measure, and this is reflected here in the size of the label of the node and in the dot size. And then we kind of clean up a little bit the graph by pruning the less important nodes, let's say it like that, in order to clear up the meaning so that it becomes more transparent. And then apply some community detection algorithm so that is represented in different colors. So this is the final product of this, or the congruency coordination network chair, where for the main source word you have identified the subgraphs which represent different meanings of the word. So this is where we start now to analyze the senses and apply sentiment analysis with modulo the sense of the word. Here are the main words of the chair, and now we will select each of these communities and calculate the sentiment value of that community, not of a single word, but of a graph. And how we do that is by calculating the available sentiment values of the nodes in the graph, and take into account also the graph centrality measures. But the problem with this calculation is that not all nodes in the graph have the sentiment value. So what we do first is we fill the sentiment values for all the nodes in the congruency graph and calculate by that formula that Ben has already shown. So we now have the values of all the nodes in the subgraph, and we can calculate the value of a specific community. So for example, of the graph chair, here I've shown the community 4, which is related to the academia meaning of the word. And it turns out that it's a positive meaning of 0.3. And in the table, you can see for the Centric net, so the main representative is the polarity value. The numbers here with 1 decimal are the original values, while the remaining 3 are the assigned dictionary values that we have calculated according to our method. And then they all are used, and according to the graph centrality measures, we come up with the value of this meaning of the word chair. And we do that for each of the communities. And this is the final product. This is the sentiment potential chair and the visualization that I think is very indicative, and it's nicely explains what we were talking about. So if you look at the meaning of the noun chair here, you see some 3 circles. Each represents the different sense of the word and different community. And on the right, you have the scale from -1 to 1, from cool tones to warm tones. So the higher the positioning of the circle, the more positive the meaning is. And this is reflected also in the color. And the size of the community reflects the size, weighted size of the subgraph. So if you see the largest community here, that is the second community, that could be the main meaning or the primary meaning of the word chair, and it's related to sitting. And it's a positive meaning, and you can see that the meaning of the word chair does not have many emotional values, so it's all rather positive, but not very positive. And this was done in this large corpora of N1010. For another example, I forgot to tell you that you also see here some horizontal lines. So the green line is the assigned dictionary value that would be calculated from the friend of a friend graph of the word chair without that additional steps of the analysis of centrality and clustering of the graph. And that analysis is shown here with this orange line, which is kind of a mean sentiment value of all the meanings of the word, and is calculated here as the average sentiment, where the size of the community also counts. And it's, of course, its sentiment value. So these are all the elements in this visualization of the sentiment of this word. Here is the another word. So in the application, we have several parameters. Lexem is one of those. So when you change the word, you obtain different graph. And here you can see the word fight, which has a negative meaning. But when you change another parameter and there's the corpus, if you look at the same word, noun, fight, in the Euro-parliamentary corpus, which contains a large amount of transcripts in the European Parliament, not sure for what period, you see that the word obtains negative meaning when connected to immigration, terrorism, asylum, integration, but also a quite positive meaning when connected to revolution, security, and justice. So you see that in the European Parliament, the specific use of the word which transpires from the corpus is more polarized, I guess. Fight can also be a verb. So the verb fight here also has polarized meaning. It can be positive when related to stand, defend, attack, but quite negative when related to quarrel, complain, dispute, and suffer. And an additional parameter that's kind of hidden, when you change a corpus, you can change a language. And then, for example, word logic in Croatian, logika, is shown here, and it has more positive meaning actually when it's related to the heart and the mind, intelligence, and wisdom. So in addition to Croatian, we have also integrated Italian and German corpora in the application, and more English corpora. Some are time-stamped to cover some special periods. As already mentioned, different sentiment dictionaries are already there and can be also used as different examples, and would come up with different visualization, different representation of the sentiment. And the semantic knowledge base is also integrated, and in the paper that was published in June, where the sentiment potential was presented, we also presented the labeling of the senses. So we automatically produce the meaning of the specific community. So to conclude, we have used NLP graph theory and some of the AE, but as Ben has already explained, we will further go probably into deep learning, or at least hope to be able to integrate that as well into our research, and further develop sentiment potential as a refined and enriched representation of sentiment of words, which then analyzes text in some specific use. And of course, we are aiming to represent multi-word expressions and in specific areas and in specific use. So that is just introduction for the next talk that Sanda will give after the break. So that's all for me. Thank you for your attention.